Hi students, this is a video on the fundamental theorem of algebra. I just wanted to mention that I am going to be checking for notes, so it is required that you watch this video and take notes on it. That is part of your homework for the next time we meet. These are some statements, and they all really say the same thing, and they're kind of review of what we've learned so far. That a real number r is the root of an equation set equal to 0, so p of r equals 0. R is an x-intercept of the graph of p of x. X minus r is a factor of p of x, and when you divide p of x by x minus r, the remainder is 0, okay, whether you use synthetic division or polynomial long division. And r is a 0 of p of x. So it's just kind of important to understand the language in here. If this language isn't clear, please come talk to me. So you can use all this information to write a polynomial function when you're given the zeros. So we're going to try that here. A couple of easier one and then one that's a little trickier. So very simply for 1a, we would write f of x equals, if my solution is negative 2 and 2, I've got x plus 2 for the negative 2, x minus 2 for the 2, and x minus 4 for the 4. And then I am going to multiply together. This ends up being a difference of 2 squares, x squared minus 4 times x minus 4. And when I multiply that out, I get x cubed minus 4x squared minus 4x plus 16. Let's try the next one. If I have zeros of 0, 2/3, and 3, I have f of x equals, for the x of 0, I'm just going to write x. For the x of 2/3, that's a little bit more complicated. We're going to go over to the side here and check that out. If x equals 2/3, I want to set that equal to 0. I could certainly write x minus 2/3 equals 0, but that's going to be hard to multiply if I've got a fraction. So instead, I want to get clear out the fraction. I'm going to multiply both sides by 3. I end up with 3x equals 2. And I'm going to subtract 2 from both sides to set it equal to 0. 3x minus 2 equals 0. This way I don't have any fractions that I'm multiplying by. So I have 3x minus 2 is also one of my factors, and then x minus 3. And I can go ahead and multiply that together. So starting with the first two, multiplying them, I get 3x squared minus 2x. I get 3x cubed minus 9x squared minus 2x squared plus 6x. And simplifying further, I'm left with 3x cubed minus 11x squared plus 6x. So I want to mention that it says write the simplest polynomial. I could write a less simple polynomial simply by putting a constant in front of this and also multiplying that through. That would give you the same zeros, but it would be a different polynomial. So when it says the simplest, I'm just using the zeros and I'm not multiplying through by any constants. All right, so the main objective of this lesson is to learn the fundamental theorem of algebra. It states that every polynomial function of degree n is greater than or equal to 1, so the degree is greater than or equal to 1, has at least one zero, where the zero may be a complex number. And the most important, really, that we're going to deal with here is every polynomial function of degree greater than or equal to 1, n is greater than or equal to 1, has exactly n zeros, including multiplicities. So if I have something like 3x to the 4th minus 2x to the 3rd plus 5x minus 3, if I want to know how many zeros it has 4 zeros. That is its degree. So it has 4 zeros. And then it may have complex solutions. So an example again of a complex solution would be something like 3 plus root 2i, right? Or maybe 4 minus I. Those are complex solutions. So we're including complex solutions when we talk about the number of zeros. Here we have a great example. Solve this polynomial by finding all roots. First thing I want to do is look for a greatest common factor. Do the terms have a common factor? And they do not. Can I do grouping? I cannot because there's 5 terms. So I need to think about what are the possible solutions. And I'm going to think about what we talked about in class today. P over Q are my possible solutions. P, again, negative 20, so I've got all the factors of negative 20, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, and then this is all over 1, so those are really what I'm looking at. And so I'm not going to show you a bunch of things that don't work and take up video time by that. I tried, let's see, I think I started with 2. I tried positive and negative 2, didn't work. Positive and negative 4 didn't work. I tried positive 5, and it turned out that it was negative 5, which was a solution. So let's look at that. So I bring down the 1. 1 times negative 5 is negative 5. I get negative 1. I get a positive 5. 4, negative 20. 16 minus 20 is negative 4. Positive 20 and 0. So I know that from this, I know that x minus x plus 5 is a factor, since negative 5 is a solution. And I've got my other factor right now is the polynomial x cubed minus x squared plus 4x minus 4. And I'm going to just bring down this x plus 5 and use grouping to factor this next one. And I end up with x squared times x minus 1 plus 4 times x minus 1. So I'm going to still bring down my x plus 5 and I'm going to drop that off, times x minus 1 times x squared plus 4. So I can set the x plus 5 equal to 0 and get a solution of negative 5, the x minus 1 and get a solution of 1, but the x squared plus 4, I need to work with that a little bit more. Let's go off to the side. If x squared plus 4 equals 0, right, I can solve that by taking square roots. X squared equals negative 4. I can take the square root, the positive and negative square root of negative 4, and I get x equals plus or minus 2i. Hopefully you remember that from the last chapter. So I end up with my factors of x plus 5, x minus 1, x plus 2i, and x minus 2i. We know that that's a conjugate pair. And so my solutions are negative 5, 1, and plus or minus 2i. So again, I've got 4 zeros, and if we look back up at the original equation, it was x to the 4th, so we should have found 4 zeros. So just as a little reminder here, if a plus bi is a root of a polynomial equation with real number coefficients, then a minus bi is also a root. The complex solutions come in conjugate pairs. All right, write the simplest polynomial function with zeros 2i, 1 plus root 2, and 3. Another one, a little more complicated. Write the simplest polynomial function with zeros 2i, 1 plus root 2, and 3. So the zeros are, we have to think about what are the conjugate pairs. So the zeros are 2i, negative 2i, 1 plus root 2. Remember, these come in conjugate pairs, 1 minus root 2, and 3. So let's write our factors out. Okay, so I'm writing out my factors here. I've got x minus 2i, x plus 2i. Then I have to figure out what to do with these irrational roots, and I end up with, I've got x minus 1 plus root 2 and x minus 1 minus root 2. And you might want to ask, why didn't I put these in parentheses? Which I could have, but I'd end up with the same thing. The way it works out, I'd still end up with x minus 1 plus root 2 and x minus 1 minus root 2. So and I've got one more, which I'm going to squeeze down here, x minus 3. So then I need to go ahead, since I'm trying to write a polynomial function, I need to go ahead and multiply these together. And multiplying, I get f of x equals x squared. Since this is plus and minus, I'm going to get a difference of 2 squares, so minus 4i squared. I squared is negative 1, so this really is for x squared plus 4. Okay? When I multiply those together. And then x minus 1 plus root 2 and x minus 1 minus root 2 is going to look like, okay, this is just a little complicated to show, so I'm going to, actually let's move this up so that we have it right up here, x minus 3. Okay, so let's look at this. Let's put it in a different color. So x times x is x squared. Let's put these, hang on. X times x is x squared. Okay, now let's do this. Let's put these in parentheses because they're going to help us. It's going to help us here with our multiplying if we have these in parentheses. Okay, so now I have minus, I'm multiplying this times this, and I get minus x times 1 minus root 2. Okay? And then I have, using the blue again, I have this times x, which is minus x times 1 plus root 2. And then I have 1 plus root 2. Gosh, then I have plus, because it's a negative 1 plus root 2 times a negative 1 minus root 2. So it's going to be a positive. And it's a plus minus, so it's going to be 1 squared minus root 2 squared. Okay, so let's kind of move down to kind of show what that looks like. I have x squared minus x, so let's distribute the x. Minus x plus root 2, x, because the x comes after that. I'm distributing the x. Minus x minus root 2x, and then 1 squared minus 2 is minus 1. Okay, so this is now x squared minus 2x, because this positive root 2x and this negative root 2x cancel out. The negative x and the negative x makes a negative 2x minus 1. So that was a pretty tricky example, but I wanted you to see it. So let's come down here again. F of x equals x squared plus 4 times x squared minus 2x minus 1, and then let's not forget our x minus 3, times x minus 3. And further multiplying, we get, I multiplied x squared plus 4 times x squared minus 2x minus 1, and I got this long polynomial, and then I'll do the last multiplication, and here's my final answer. A lot of work. A little bit complicated when we have those, these two roots that are underlined by the red here, the 1 plus root 2 and the 1 minus root 2. A little complicated, but hopefully you can look back on that for an example. At this point, you can stop this and you can come back and refer to this for any of the word problems if you want to see an example, like some of the word problems that deal with geometric shapes. So you can go ahead and stop here, or I'm going to go ahead and just show this example and you can come back to it if you feel like you need it later to study from. Okay, so this problem is telling you that the volume of this silo, which is a hemisphere and a cylinder, okay, is 2,106 pi cubic feet. Just find the radius of the silo, which they've marked as x. So I've got the volume of a hemisphere, which is 4/3 pi r cubed, and I'm multiplying it times 1/2 because it's a hemisphere. And then the formula for the volume of a cylinder. And let's go ahead and put in the values that we have. Okay, and then let's go ahead and simplify it. Half of 4/3 is going to be 4/6, which is 2/3. 2/3 pi x cubed plus 20 pi x squared. And getting rid of volume and putting in what it's equal to to 2,106 pi. You can see that we can easily just cancel pi out. We're really dividing everything by pi, all the terms by pi. And then we end up with 2/3 x cubed plus 20 x squared minus 2,106 equals 0. Factoring out 2/3, I'm left with x cubed plus 30x squared minus 3,159 equals 0. I just multiplied by, to factor 2/3 out, I just multiplied by 3/2. And I can't, I don't have any method of being able to factor this because it's cubic and it's not a sum or difference of cubes. Looking at the possibilities, 3, 1, 5, 9. If I add 3 and 1, I get 4 and 5. I get 9 and 9 is 18. When I add up the digits, I get 18, so it's divisible by 3. So I could certainly try plus or minus 1, plus or minus 3, plus or minus 9. Those would probably be the ones that I'd start off with. Just to shorten this up a bit, it turns out that if I do 9. Let's see what we get. 1, 39, and 9 times 39 is, I didn't put a placeholder in, so let me just put that in right now. This was 0, and this was negative 3,159, so 9 times 39 is 351. 351 times 9 is 3,159, gives us 0. So plugging this into the quadratic equation, I end up with x minus 9 times x squared plus 39x plus 351 equals 0. and I plug that into the quadratic equation, and I'm not going to show all the work here, but I end up with negative 39 plus or 39 over 2 plus or minus 3 root 13 over 2. So then my solutions are 9, and this, if I put this in a calculator, I get approximately negative 24.9 and approximately negative 14.1. And those are my solutions. So kind of went through this a little quickly, but I wanted you to mainly see how to set it up, not so much grappling with the numbers. Okay, see you later.